guys, welcome back. We're going to fix free response question 1. So I'm just calling this all free response question 1. So let's do it. Put 8 values in a spreadsheet. Okay, so we need to put 8 values in a spreadsheet. That's the first thing we need to do. So if you saw the earlier videos, you probably actually know how to do this one now, maybe. So let's just review. We open a spreadsheet, and this is called, we're doing soft drinks. So I'm just gonna call this soft. Okay. And so I gotta put these 8 values in here. They're in there. Okay, 8 values in, and I'm gonna make the calculator do all the work. This is a T interval because I didn't ask yes or no questions and I have data. I just typed it in there. So I named my data soft drink or soft, and I have to make sure, what is the confidence level? 95. Okay, beautiful. Enter, bada boom, bada bing, it's gonna do everything. X bar plus or minus margin of error. So in this question, there wasn't a lot of room to show your work. So I wasn't looking for state, plan, do, conclude. I was just looking to see, can you construct and interpret a confidence interval? Okay. So hopefully you can. So the X bar plus or minus the margin of error was 22.5 plus or minus 6.01. Okay, so where do these numbers come from? This 22.5 plus and the 22.5 minus, or just right out of your calculator as well. So they gave us the T lower and the T upper. Make sense? So, oh, I called it soft this time. I guess the other day when I was writing this out, I called it sugar because it's the sugar content. You put the values in the spreadsheet, you name them sugar, hit menu, stats, and T interval. Then select whatever you name it, if you name it sugar, from the list. Make sure to leave the confidence level at 95 and hit enter. Then summarize. So this would not give you full credit, but this question I was specifically seeing, could you manually enter these and find a T interval? So we are 95% confident that the interval from 16.5 to 28.5 grams per serving captures the true mean amount of sugar in this manufacturer's soft drink. These words I copy from the question, so I do not get creative. I just kind of restate the question they are asking me. What were some other things I was looking for in the problem? Well, you did have a table B, so you should have noticed that your T star is 2.365 because your degree of freedom was 7, which degree of freedom is 8 numbers minus 1. Okay, awesome. Let's do the other part. So what do we got here? We have this formula. They actually showed it up here a little bit, and I'll give you a reason why the T turned into a Z. So researchers would like to estimate the amount of time it takes to finish a task. They want you to do it within 0.5 seconds. So that's our margin of error, which is why I plugged in 0.5 for the margin of error. Okay, what's T star? Well, I don't know how many people. I don't know N yet. So I can't find the degree of freedom. I can't find the degree of freedom like I did here and then find T star from the table. So when you do not have N, you must use Z star. So I'm forced here to use Z star, or 1.96, because we are asked to do a 95% confidence level. Okay, we're pretty much done. The formula states use Z star, I guess, when you don't have T, and then your standard deviation, which is 4, all over the square root of N. So let's just walk through the algebra here. I recopied the question, just to be clear. I swapped spots, right? The square root of N was on the bottom and 0.5 was on the top. I swapped spots there, rewriting. Left this on top. Then I squared both sides, right? Squared both sides, so now I just have N on the left, and on the right, I went ahead and calculated all this stuff. 1.96 times 4 divided by 0.5 was 15.68. But I squared both sides. So I got 245,862 which means we have to round up to 246 people because we don't have anyone that I've ever met that's only 0.8 of a person. Awesome. Okay. Fix that test. The last piece we got to do is we got to state, plan, do, conclude, don't we? It gots to. So let's do it. Most of you don't have this piece of paper back, but you'll be getting it soon, and I'm going to put it on this video. So let me just flip through here. One second. Beautiful. I got a nice clean copy here. Okay, so this is free response question number 2, and this is how you get your badge for constructing a confidence interval for P. This is how you get your badge for constructing a confidence interval for P. You have to be able to state, plan, do, conclude. So let's do it. Number 1, we have to actually state it. So we will perform a 1 sample. We don't have to do H sub O and H sub A, but in our plan, we have to do each of our conditions. So 10% condition, since N is 300, right? N times 10, or 300 times 10 is 3,000. It's safe to assume our population is at least 3,000 or greater. All right. Safe to assume our population is at least as great as 10 times the sample. Okay, random. Where was the random? Yes. And our test for normality. So our test for normality, when you ask a yes or no question, is called large counts. Okay, so what does that mean? It means at least 10 yeses and nos. So n times p has to be greater than or equal to 10. N times 1 minus p has to be greater than or equal to 10. So what does that, Well, you could go through, let's figure out what P is first. So kind of off to the side, P is, what is my proportion that could roll their tongue? Let's calculate that. So back to the home screen, back to calculate, 68 divided by 300. 0.2266, so 0.226 repeating. So what is this formula doing? It's doing 300 times 0.226 repeating, which is 68. And we know that's greater than or equal to 10, so that's good. And then 1 minus that. So back to the calculator, 1 minus my answer is 0.773 repeating. So 300 times 0.773 repeating would be 300 minus 68, or 232. That's also greater than or equal to 10, so we're good there. So I stated, I planned, it's time for the do, folks. Okay, so what is my do? Well, to create a confidence interval, if it was X bar, but it's not, right? It's our P hat plus or minus Z star times the standard deviation, right? P times 1 minus P all over N. Okay, that's our formula. I don't have the Z star memorized, and I do not. Oh, I do have a table B. So let's figure out what would be my Z star. So what is my Z star? So going down here, it looks like my Z star for 90% is 1.645. Okay, so do means come up with your formula and plug it in. So my proportion I calculated a minute ago is, my sample proportion is 0.226 repeating. This number I found out of table B, 1.645. This number I still have 0.226 repeating, 0.773 repeating, all over N. I talked to 300 people. Okay, do I actually have to calculate this? No, Mr. Calculator will do it all. So let's make him do it. All right, this is a one proportion Z interval. So could you have also said this? We will perform a one proportion Z interval. Absolutely. Don't forget your Z. So I went up and actually one sample confidence Z interval for P, even better. Made it even more specific. So success, I can roll my tongue. I talked to 300 people and my confidence level is actually 90. Bada boom, bada bing. It did everything for me. My p-hat matches. My margin of error, so that's nice. I can rewrite this. So my p-hat is, I'm just gonna round now, 0.23 is my p-hat. Margin of error is 0.04. Okay, beautiful. It calculated all that for me. And then I'm ready for my conclude. State plan do conclude. We are 90% confident that we are going to get this badge. Confident that the interval from blank to blank captures the true, copy it from the question, captures the true proportion of adults who can roll their tongue. Okay, so what's the this to this? That's this plus that and that minus that, but you don't even have to do that. Your calculator did it. That's what this C lower and upper is. So I would round this to 0.19 and 0.27. I'm gonna call it a day. Good job, guys. See you later.